Hello, my name is Joel van Stie. I am a senior design engineer and consultant at TrelleborgMarine&Infrastructure, and I'm responsible for all the design of all Trelleborg's tunnel seals. I've got more than 12 years of experience working in tunneling and have worked on a diverse range of immersed tunneling projects. Based on this experience, I also advise on tunnel renovations and refurbishments. I specialize in rubber sealing in immersed tunneling, and in this video I'm going to be talking to you about best practice approaches to creating immersed tunnels that are watertight.
Hello, my name is Nico Brink, a design engineer at Trelleborg, and together with Joel van Stie I will talk you through the world of immersed tunneling, which I hope will give you an impression of all the work that is performed and products that are used in order to make a variety of global projects to a successful end.
So, in general terms, an immersed tunnel is constructed from a series of prefabricated sections, each ranging between 100 and 200 meters long. These structural concrete elements are manufactured in a casting basin or dry dock and designed to float so they can be transported to the tunnel location before they're being immersed. Each element is lowered into a trench that has been dredged at the bottom of the waterway and joined together. The trench is then backfilled and the tunnel finishes are completed from the inside. Although the process may look simple and the technique has existed for quite some time, it is exactly this simplicity that makes it so effective.
Immersed tunnels are different from bored tunnels but have some interesting advantages. Firstly, they are suitable for short and shallow crossings in soft soil. This is advantageous because it means we don't have to dig deeper and we are able to keep the tunnel as short as possible, which is in turn presents economic benefits. Another advantage is its flexibility in shape and dimension. We are not restricted by having to make the tunnel round, and in fact, their rectangular nature means the tunnel can be wider or smaller as the tunnel progresses. And you can have different shapes along the cross-section of the crossing itself. This means you can start small and end up bigger, useful if your tunnel has entrance or exit lanes at the end. And because immersed tunnels can be short, this approach is very practical in urban areas where entrances into and exits out of the tunnel are often located close to a shoreline or riverbank.
Let's take a look at one of Trelleborg's most exciting immersed tunnel projects. We helped with the construction of the Hong Kong-Zhuhai-Macau Bridge and Tunnel, built to improve the flow of traffic between Hong Kong, Macau and Zhuhai. It's the world's longest deep-water immersed tunnel at nearly 6 kilometers in length and has a lifespan of 120 years. This was one of our most challenging projects ever. Water depths of over 40 meters and rough open waters, trafficked with the world's largest ships, meant watertight seals were even more important. Also, Hong Kong is located in an area where seismic activity is common. So we needed to make sure the seals were resilient to earthquakes and other ground movements. We used more than 250 omega seals in different sizes, plus 34 GINA gaskets to seal the tunnel. And these gaskets spanned 90 meters in circumference. We also used rubber water stops with vulcanized strips so that the concrete sections were watertight, even when there was a risk of an earthquake.